some aspects of the models that we've been building. And really this gets to the issue of sort of model scope and the issue of model boundary. I had talked earlier in an earlier presentation about needing to be clear with a given version of your model which things are going to be endogenous, that is produced by the model, which things exogenous, specified to the model, and which things ignored, which things left out of the model for now, often consciously so. Within the context of this decision, there's a number of motivations that might incline us to include components within the model. And one of the considerations is that we may wish to have a model variable that corresponds to observable quantities. So when we're calculating the model, when we're running the model, we can compare the values generated by the model on the one hand to quantities that are observable from the world. Another factor that might incline us to put a component into the model is if we're concerned about how it will be affected by an intervention. We want to capture the effects of certain particular interventions. Maybe there are interventions that involve interaction with parks, for example, or interventions that involve aspects of the food environment, subsidies for good nutritional foods. And in order to capture those effects in the model, we may need to represent certain features of the situation in the model. We may need to represent, for example, people's park-seeking behavior, or people's physical activity as it is supported by different built environment. So, something that might incline us to put into model is it's a key mediator for intervention effect. And we want to see the ripple through effects of the intervention on the person's behavior and on their health state. We need to represent this as kind of a nexus for how the two come together. In other cases, the issue is not so much that it serves as a mediator for the intervention, but it's affected by the intervention. And if we're concerned about transfer effects, that a given intervention might privilege or benefit certain groups and disadvantage other groups, it may be that we want to have a certain factor within the model that will capture that effect. For example, we want to distinguish people by socioeconomic status, or we want to distinguish them according to education level, or distinguish them according to rural versus urban. It's not so much because necessarily it has a direct impact on mediating the effect of the intervention, but rather we're interested in seeing if the intervention ends up disproportionately benefiting one group or disadvantaging another group. There are cases where we need to, and this is quite common, where we need to plausibly put a certain feature into the model to capture the necessary dynamic behavior over the time frame of interest to answer a research question. That for basic face validity, it seems very likely that we're going to need to account for some effect. And we put it into model because it's an important component of the causal pathways that need to be captured to accurately assess the impact of a given intervention or to assess the evolution of the baseline. And finally, this sort of a factor may be included in the model because for stakeholder credibility, it's viewed as critical. We can't go before the stakeholder, present them with our model, and have them be expected to have confidence in it unless it's captured a certain feature of the situation. Sometimes that is because the stakeholder involved is an expert on certain areas of the system, and they've encountered certain types of dynamics in that area of the system, and they want to make sure that the model reproduces it. In other cases, the model may be unrecognizable to the stakeholder in terms of its depiction without this feature in it. Maybe it's spatial layout, maybe it's aspects associated with the sort of background of a given person in the model. And so we need to capture it to show the stakeholder that, yes, the model is capturing important features which they're familiar with. Jeff talks about how in some models there may be no need from a technical perspective to yet include, for example, geography in the model. But for certain stakeholders, it makes it much more compelling and much more powerful if you have that geographic overlay to the model. Even if it's not making central use of it yet in a GIS sense and reasoning about details of the physical environment, the availability of green space, aspects of the food environment in certain regions, having that geographical presentation of the model may be very helpful for building stakeholder buy-in and interest. We're going to be seeing geographic models starting tomorrow, including models of the food environment and food deserts. But in the meantime, it bears noting that geographic context and showing it can be an eye-opener for many stakeholders as to the relevance of this sort of modeling. Whether it should be or not is beside the point, that if you want to have a useful model that actually gets used, sometimes the capacity to represent those things will help you take it further, help you get in through some doors, and allow you to then better educate the stakeholder as to really what's most important to capture in the model. Now, an important issue within this area is this factor of when we decide what's in the model, what's left out of the model, there needs to be a decision as to what degree we represent certain features of the situation as endogenous versus exogenous. We might want to represent them in the model, but the question is, does the model generate them, or are we specifying them to the model? An example might be networks, associated with networks, which we'll be seeing soon enough. To what degree do we want to specify to the model fixed network structure that we assume, and to what degree do we want to allow that network structure to emerge out of people's preferences, out of association with people with similar beliefs, habits, out of, in other words, assortivity according to their background. To what degree do we want to characterize that in the model? To what degree do we want to presuppose, for example, a certain level of mobility on the model? And to what degree does that mobility reflect in an endogenous way people's access to transportation choices, people's built environment in their area, people's surrounding context in terms of the availability of things like sidewalks and paths, etc., availability of spaces in which to engage in recreation. Do we pre-specify the mobility for individuals and capture, for example, their contacts with other people and the transmission of norms through that with the mobility being pre-specified, or to what degree is it generated? Now, there's a real set of pressing trade-offs here. A model can only have so much in it. Ross Hammond talks about having a complexity budget for the model. You can only spend so much. You can have a model that goes really deep in certain areas but is comparatively narrow, or you can have a model that's very, very broad but not deep in any one area. And I believe that is true. Jeff has spoken of similar things. And from my own experience, it's true. We have limited time, we have limited resources available, limited human resources that we can invest into a model, and we need to channel that investment. However, what is also true is that the use of software, your choice of software, will help you go further with a limited complexity budget. If we had to build up the sort of models we've been building already using NetLogo, or if we had to build them up using Repast, we wouldn't be yet past the stage of the first model, probably. And so that time, that limited time you have goes to making less progress in terms of the model. So there is a limited complexity budget, but how far it gets you depends very much on the software you're using, the facility with which you can wield it. Now, however, we inevitably come into trade-offs. Do we incorporate this thing into the model or do we not? And some of the considerations that you want to have, I listed on the previous slide, that might help prioritize what things do you put into the model, which do you not. There was a question before lunch that partly instigated my giving these slides right now about, how do we represent births in the model? Do we represent a whole state chart with a pregnancy state associated with it? Do we represent males as distinguished from females? Do we represent the age structure of the population as it affects fertility? And models will differ in how they answer these questions. They'll differ in terms of their goals. There are extremely stylized models out there. They'll put entirely aside the issue of age, entirely aside the issue of sex, and focused on a few small features of the situation. And then there's others that will have very articulated representation. We'll be seeing them particularly starting tomorrow in some guest lectures and some lectures from myself on particular models. Within this area, we'll often have this choice: do we endogenize a factor or not? And endogenizing has some benefits. It gives extra flexibility to capture effects of interventions. If we have in our model a representation of mobility as endogenously produced by the nature of the physical environment, rather than being pre-specified, it follows that if we modify in the model through an intervention that the assumptions about that physical environment, that it will ripple through to effects of mobility, which might in turn affect physical activity, sedentary behavior, might in turn affect assortment of individuals and transmission via social networks. So endogenizing factors lets us examine more flexibly a broader set of interventions and allows us to examine a broader set of exogenous scenarios that operate through that factor. It also will often provide greater robustness in the context of changed assumptions, for example, about how the physical environment is generated. There's any number of different models I've worked with in infectious disease where, for example, you might pre-specify up front a contact rate that people have with each other. People have a certain contact rate, certain number of persons per week with whom they're in contact. Perhaps it's a contact that involves standing close enough for airborne transmission. Maybe it's one associated with transmission through bloodborne infection from sharing needles. Maybe it's sexual contact. In any of these cases, you might posit a certain level of contact. And often that assumption is fixed. You're assuming a certain fixed level of contact over time. And that will get you a certain distance, but one has to recognize that there's evidence for substantive change in the level of contact as time continues in the course of risk, in the case of sort of perception of risk. In the case of a bad H1N1 outbreak, or in the case of SARS, people's contact behavior changed. They engaged in selective mixing, more selective mixing. They engaged in better hygienic practices as well, but they engaged in social distancing. And so, if we want a model to kind of account for behavior over time, it will often do so more robustly if we endogenize it, if we have a component that's based on risk perception. And, such a model can often support more ready translations to other contexts if we endogenize things, because it automatically generates things that otherwise have to be told to the model directly. So if we translate our model from Sydney to Melbourne, and it has endogenized the impact of physical environment on mobility or in sedentary behavior, then that's one less thing to program in directly to the model. It results from the local context, perhaps from information that can be read from GIS databases. On the other hand, if we keep greater detail on the model, if we endogenize more things, it often does require more implementation work and sometimes more data and sometimes more theory to be leveraged. Okay, exactly how is people's mobility pattern and level of sedentary behavior dependent on their physical environment? So this is a trade-off. It often involves more investment. And so when we talk about a model in incrementally evolving in a step-by-step way, we're often talking about weighing on an ongoing basis, what do we add next? What do we put in? What do we endogenize that has previously been fixed? For example, I don't know how many models now there are, of aspects of the care environment. This is something that's going to be talked about next week. Service delivery associated with chronic diseases, where we're assuming a certain level of self-management of a disease, and often that's positing a level of social support behind that. There's a level of help you get from your spouse or you get from your kids, and endogenizing that might allow you to simulate burnout effects, for example, the degree to which your spouse or your child will be overwhelmed because they have they have a parent and a parent-in-law to take care of, or a sibling who's just overwhelmed by needing to care for a sick brother while herself juggling two jobs. So endogenizing features allows us to investigate interventions, allows us to investigate what-if scenarios, but it can require this sort of theory. Okay, so endogenous versus exogenous, it is a distinction we make not once, but on an ongoing basis, and we're constantly trying to learn from the model as to what might be it might be sensitive to. We'll be discussing sensitivity analysis in a coming lecture, and then based on what it's really sensitive to, we might endogenize something for an iteration or two of the model. Figure out what we've gained from that, figure out if it's really expanded our ability to investigate interventions, figure out what we've secured in terms of greater insights from the model, and then we'll figure out, does it stay, or do we roll back to a model where that's fixed, where that's exogenous? An ongoing dance associated with the model. Those are some comments on endogenous versus exogenous. Are those helpful comments to people? This is an ongoing issue, and some of the most exciting things you can do with models is to endogenize something that you know is important and has been fixed. We work with a model on our Ministry of Health, which involves options associated with when someone's discharged from acute care in a hospital, they go to community care options. Long-term care facilities, home is another common one, but other ones are personal care homes offering a somewhat lower level of care than long-term care. Sometimes they go to rehab facilities, etc. And within this model that we've been operating with, a fair bit of that has been fixed. A certain fraction go to care homes, a certain fraction go to personal care homes versus home care in the home, versus long-term care facilities. And endogenizing it raises the possibility that you will capture, for example, effects associated with limited capacity for nursing homes, limited capacity associated with personal care, the impact of different decision-making a person may have as to where to go based on proximity to loved ones, etc. And that may reveal over time, and in response to interventions, very different patterns than if you had fixed it, if you had viewed it as a constant, the assumption about how their behavior changes. Similarly, we could create a model of physical activity where we assume a certain fraction of the population is physically active, a certain fraction with moderate, a certain fraction with little, and simply fix that as a constant, and then evolve to a model where that depends on the nature of what's around them in terms of the environment. It depends some on their contact with others who have different weight or different norms, etc. So often it's relaxing these assumptions that allow us to take our insights to the next level. We can ask what-if questions that weren't possible before. Okay? So some comments there. I also wanted to make some comments, and by the way, I have a whole bunch of slides if people are interested on sort of particular examples of sort of how you might broaden a model's decision over time. Often we'll start with kind of a crude representation of things, and then we'll go sort of expand it so it's more flexible, see what the impact is, and then go to a longer term strategy. And I've provided some examples, with sort of smoking, different ways you might characterize the situation, different levels of detail that you might use for different contexts, and same thing with modeling of HIV spread. Different interests lead to need for different levels of representation, and then mixing between individuals as might affect spread of norms as well as spread of pathogen. Okay. Wanted to talk about another feature of the situation, though, which is this issue of causal mapping, okay? Mapping out a model up front. The reflection here, folks, is that modeling takes place. This is one of the things I was going to talk about yesterday, but I'm instead going to weave it in to components of this. Modeling goes through a set of stages. Often we start by conceptualizing our problem. What is it we're really trying to get after here? And framing it so that we can try to figure out what's needed to address it. If we don't do that framing well, we risk having a model that has lots and lots of things put in it just in case it's irrelevant to some question you may be wanting to ask. But if we have a fairly clear idea of questions, it will often serve as a logical knife to cut away extra complexity. After problem conceptualization stage, we often go to the stage of problem mapping that I'm going to be talking about. Systematically trying to sort of think through, not yet at a fully quantitative level, how different variables relate to each other. In statistics we have influence diagrams, right? We'll have diagrams that we use, for example, for path analysis that show posited linkages between variables, or for structural equation modeling. Qualitative problem mapping, we go through a similar process of using very graphical depictions. In the model formulation stage, we're taking that to the next level to build a model that's actually simulatable. And we've been doing a lot of that, putting together pieces needing to simulate the model. For that, we need to fill in a lot of additional details that aren't present here. These include formulas. Exactly how does a woman's likelihood of giving birth depend on her age? Exactly in what way does an individual's chance of developing diabetes depend on their weight status? Model formulation requires filling in a lot of the details so it's an unambiguous model that can be simulated precisely. That doesn't mean it's necessarily an accurate model. It could be, it might not be, but it's precise enough that you can simulate it. Following that stage is often a stage of model calibration, where some of the things that you're not so sure about the estimates for, you try to calibrate so the model reproduces observed data in the world. We're often asking about counterfactual situations with the model, but in order to develop enough confidence in the model to want to run those counterfactuals, to make it worth our time, we want the model to reproduce historic data. And in a best practice, you may build the model with a subset of that data, and then test it against, seeing if it can predict, seeing if it can generate the data we didn't tell it about, but that we secretly have. This is a process called cross-validation. Okay? And that's a step in building confidence in a model that can be very valuable. And the observation here is there's only so much wiggle room the model has. You're simultaneously in model calibration, not just getting it to match one time series. Often you may have it try to match multiple time series, or try to match multiple data points in one time series. And you need it to be matching all of these at the same time for you to develop confidence it's reproducing features of the situation in many cases. And then you might use it to look at counterfactuals where there's very little data available. Model testing overlaps some. I put cross-validation here, but it involves sensitivity analysis and robustness tests, extreme value tests, etc. And then using the model in various forms and bringing it to stakeholders. We're going to talk right now about this qualitative problem mapping. Okay? This mapping out of a problem. I should note this whole process is iterative. We build the model incrementally. We re-examine what the scope is of the model on an ongoing basis, map out maybe how those new features fit in, and integrate it with a model, go through some stages, and reiterate. And of course, the mental model is one of the key deliverables. Now, in system dynamics, we make heavy use of what are called causal loop diagrams. And these causal loop diagrams are designed to depict the causal relationships between a set of variables, where the relationship between variable A and variable B, the dependence causally on one variable on another, can be indicated by an arrow. So in this case, toxic stress is posited to have an impact on allostatic load causally. And there's a polarity associated with that impact. You can see this plus. And what that plus means is all other things being equal, if toxic stress rises, allostatic load will tend to rise compared to the value it otherwise would have had. In other words, raising toxic stress will tend to raise allostatic load compared to what it otherwise would have been. Similarly, a negative feedback, or a negative polarity indicates a change from variable A to variable B in the opposite direction. So, for example, here, increase the level of toxic stress in the environment of a child may lower the child's capacity for self-regulation, all other things being equal, compared to the value it otherwise would have had. Models of this sort, I don't have time to go into great detail, but models of this sort enjoy many benefits. It is this sort of model with which Peter Hoffman and others work in the system dynamics area will engage with communities, with high schoolers in inner city, engage with communities in rural India, engage with communities that are struggling with inner city obesity. And within half an hour of encountering a model framework like this, people can start to contribute to these sort of interactions. They could start to sort of say, I think there's a missing link, I think we need to expand this. And these include high schoolers, talking about dynamics of bullying within their school, etc. Very, very helpful to elicit mental models, to elicit perceptions. You're not necessarily eliciting the truth about the situation, but you elicit perceptions, how they think the thing fits together. Peter tells a very moving story about using a model like this. He went to India in this rural village. He's worked in a number of places in India. And he went to a rural village where they were dealing with issues having to do with deforestation and erosion of the soil's loss of crop productivity. And they were greeted by a large group from the village, and they went into a village hall where they started engaging with this group. And they noticed that this group was entirely a male group. There was not a single woman within the group. And a lot of the stories that these males told about what was going on had gender-related features. So women had to walk hours to go get water from a source that was hours away and walk back. And in order to feed their families, they had to cut down firewood and bring it in, and that contributed to deforestation. They built up a model like this, and it had imported cows versus local cows, etc. A lot of features. And then he talks about how during this meeting, a woman walked in to find her husband. Her husband is there, and she needed to talk with him. She walked in, and she looked, and she saw this diagram. And she sort of stepped back, and for about 5 minutes, she watched as the men talked about it and improved the diagram. And then she walked up, and she said, no, you have this part wrong. You know, this is how this really works. And she spoke from authority as someone who was in the trenches for certain of these issues. And she said, you've missed, two key connections here, and you need another variable for this. The point is, this is a woman who had no education beyond certainly the high school level, maybe the grade school level, and she was able to contribute to that conversation. This is not a small matter. If you really want to understand what's going on, at the trenches level, that's a real asset. What does agent-based modeling have at a similar level? Well, I have to salute Jeff here and Joanne for their pioneering work in this area, where they have been examining alternative formulations that might work in the agent-based and hybrid modeling area. Causal loop diagrams can get you pretty far, and I have done sort of group model building exercises with causal loop diagrams to translate into agent-based models. But there's some challenges there, and it doesn't tend to map neatly onto an agent-based model. We sort of think about, okay, how do these factors link to each other, these variables, and that's great, and that might shape, what we build into the model, but there's not that ready understanding about which of these variables are at the individual level, which of them are at the global level, which are at the level of a community, which are the level of a school, and often we are interested in these nested contexts in the model. I was speaking with Ali about this not long ago, and there was a discussion there about the need to represent these multiple levels of context. And we'll be seeing an example, a hierarchical example, where we do exactly that. We have people and cities, or neighborhoods and cities and regions. It's a very powerful tool. But that's not captured in a causal loop diagram. In causal loop diagrams, we typically sort of flatten the whole thing. We also don't really think about which of these effects are in one sort of actor or another actor. They're all kind of smushed together. Also, with agent-based modeling, as with discrete event modeling, we're often at a different distance from the system. Within system dynamics, we talk about patterns, capturing patterns, dynamic patterns over time. We talk about flows that abstract away from the details of particular occurrences and rather deal with rates of flow. How many people are developing diabetes per month, something like that. Whereas in agent-based modeling, the focus is going down to that level of the individual, and for that individual, becoming diabetic is an event. Moreover, in this context, ladies and gentlemen, something that is feedback here. Let's suppose the greater the prevalence of smoking among teenagers, the greater the peer pressure for new teenagers to start smoking, the greater the prevalence of smoking among teenagers. That's a feedback loop from a system dynamics perspective that might be captured. It's a feedback from an aggregate perspective. At the level of individuals, it looks rather different, that effect. It's not a feedback to the same individual. It's, I'm starting to smoke causes Jeff to start to smoke. Man or wise, to be honest. And with good reason. But, I'm influencing Jeff here through peer pressure. It's increasingly hard to imagine. Jeff might influence me in some way, but it's not a feedback back to Jeff directly in terms of, through the prevalence of smoking, causing him to be likely to start smoking again. So there are feedbacks at an aggregate level that don't translate to feedbacks at an individual level. And so, based on this, I was musing with Jeff some time ago, how do we adapt this to an individual level? How do we adapt it to an agent-based context? And then Jeff and Joanne just did it. cut through the chase and just said, let's go ahead and do it. And I'm not doing justice to this. I actually have some photos, which I have somewhere, which I'll have to dig out, showing the craft type use that went into this with string and sticky tack. What do you call it? Sticky tack? Glue tack. But basically it involved having a depiction for your model of one or more types of agents. So this is like a person in the model, and you depict, okay, what are their aspects of state? What are the different states that they could be in here? Never smoker, current smoker, former smoker. What are the actions associated with them? Here are transitions between these states. Initiation of smoking, quitting smoking, relapsing into smoking. And characterizing parameters or properties associated with that agent, for example, their sex and ethnicity. Potentially calculating, sort of characterizing where interventions fit in. What things do they modify? Notice I've taken the liberty of sketching out in one of two fashions, either with a state chart or a stock and flow diagrams, some of these aspects of the dynamics. Hybrid modeling supporting both, and with some continuous dynamics, particularly regulatory dynamics, having this be more fruitful. And these components capturing the state's actions and rules. The fact that you can only fall back, you can only quit smoking from a current smoker state, or relapse of smoking from a former smoker state. And then there's some aspects of the environment which might be geographic. We might place this into a map of sorts, or point it to a map, but we might sort of associate them with a network that's indicated here with a distinguished mother, and then peers within this environment, instead of being in one group here. So within this context, we are kind of sketching out in this kind of silhouette sort of fashion some of the same types of considerations as to what's in the model, and we might even use polarities here to label things. And in fact, I believe in our string version of this we did that. We use polarities to indicate relationships, and I haven't drawn those relationships here, but well, there's a few shown here, and we could indicate polarities with them. But this sort of diagram is very useful for trying to unpack conceptual thinking about what things might be relevant and how they relate to each other, and unpack it to sets of agents and the characteristics of the agents. And what's key here is that this allows you, this is something that's accessible to non-technical stakeholders. You can have a discussion about it in a group context. You can have people pointing at it and critiquing it, because you're putting it out there explicitly, and you can quickly revise it in a way that would be more cumbersome if you just put it directly into any logic. This is not executable. You can't say exactly what the consequence of this will be, but it captures many features of the situation, allows us to iterate during the early sessions before we put it into our modeling software. So this sort of systems map is something that we're working on. Now there's other types of map useful for building up other models. For example, in a model of contact tracing for TB, which I worked on with one of my students, Yuan Tian, we had a representation, a quite articulated representation of the contact tracing process that was captured by the model. We might use kind of a depiction of the stages of that process up front to characterize how an individual progresses through the system, and that might be, within an individual here. And we might show some aspects of the linkages between multiple conditions, showing linkages between variables. There's some more technical types of description, which I'm tending to frown on these days, but which we use as software engineers to kind of illustrate features of a model, but what types of information are associated with a person and what sorts of actions are associated with them. So those are some aspects of model conceptualization. This is an extremely important and one of the more elusive stages of modeling. You know, what goes in the model? What's the implication? Should we put this in or should we not? And the general principle I like to advertise for my students here is what we call in software engineering the Yagni principle. Y-A-G-N-I. And that stands for you ain't gonna need it. So the idea here is you exercise deliberate and ongoing restraint as to what you put into the model. If there's uncertainty, you err on the side of not putting it in yet, building a model that is simpler, and then trying to use the insights from that to decide, do you put it in? Just because it's going to eventually be needed, you're convinced that, doesn't mean you put it in yet. And sometimes you'll find, again, your priorities change as you experiment with the model. So, trying to capture that kind of minimalist model, even if you know it's embarrassingly sort of impoverished, it's important for the learning that you go through that stage. Models are not successes or failures, you know, up front based on whether they capture, you know, the obvious features of the situation externally. Some of those features may be obvious, but they may not be relevant to your model. Hair color is obvious, but it has limited impact on many aspects of health behavior that are of central interest to your situation. So remember, and forgive me for saying something so obvious, but it gets easily forgotten, that we are not trying to reproduce the world in this model in a precise way. And we should not hold it up and say, well, it's missing this, so it's obviously not valid yet. It may be fit for use in its current form, even though it abstracts away from many details. I have a lecture online, which I doubt I'll be able to give to you, but in fact several lectures online where I talk about stylized models. And there's a long and powerful history within both system dynamics and Asian-based modeling in using stylized models, very simple models to get profound insights. These models strip away almost everything of interest in the situation. They show how just extraordinarily simple assumptions interacting can explain a lot. So you'll find videos on me, and some of the models there are for example, the Schelling segregation model is probably the most notable one, showing how profound patterns of segregation can emerge from modest levels of preference on the part of individuals, even absent residential steering, even absent predatory lending policies, even absent, overt racism in terms of to whom a house will be sold, etc. There can be emergence of clustering of individuals because of slight preferences. But there's other models too that have been profound in this sort of way because of their simplicity, not in spite of it, but because of it. So, we're struggling with our language these days, those of us who teach modeling, whether we distinguishing empirically grounded models and theoretic models, or whether we call them, data-rich models and ideological models, or modeling for insight versus modeling for prediction. We use different terms for it, but the fact is that models come in various levels of articulation in detail. And we need to recognize that there's contributions to be made in multiple phases here, but that there's certain uses for which a given model will be fit, and we don't want to put it into any use at all after it's built. Okay? So those are some general comments here at the conceptual side, and I will keep on looping back to some of these pieces in the next few days to emphasize some components. Any questions on these issues before we dive in once again to some hands-on learning? Any questions? Yes.
When we get to the model of our companies, I was thinking why the get to comment a little bit on, from your experience, how necessary is it then to involve decision makers, partners, etc. in the modeling? And the reason why I'm asking is I agree with that in principle.
Yeah.
I agree with that in principle.
Yeah.
But first of all, it can be time-consuming and costly.
Mm-hmm.
And so, is there a return on that? Secondly, we've got a system here for drugs and for health technologies. For drugs in particular, drugs is a good example. With the pharmaceutical companies to qualify for tax subsidies of their drugs, have to submit economic evaluations, interface models. Rest assured, they do not develop their models in the public domain. They develop them in the private domain. And the public domain spends a fair amount, often to people in this here, to bust their models rather than play with it. So, and that model, that way of working is going to expand as we increasingly rely, as we increasingly require people to justify their interventions economically before subsidised.
Right.
So I just want some reflections from your experience about how necessary it is always to involve decision makers, players.
It's very interesting, and I will try to make some comments from my experience. I would turn to the sage from Sydney for his insights here, because his also go back decades. But I'll make some preliminary comments. I will tell you that my colleagues as modelers, there's very strong divergence of viewpoints on this. I have some of my colleagues who are eminent, well-respected modelers, who are very dismissive of this idea. Very dismissive of this idea. They've spent their life with copious access to large data sets, and they believe that modeling is fundamentally technocratic it's a technocratic activity left for experts, and they believe in the big science model of modeling, big science idea of modeling. That modeling projects like serious astronomy projects are not for the amateur. You can kind of tinker around the edges as an amateur in astronomy these days, but if you really want to get work done, you need a massive telescope, and that's tens of millions of dollars or hundreds of millions of dollars, and that's not something where an amateur is going to be able to play effectively. And so they believe that, look, this is stuff left for experts. We have our data sets, including we have electronic health record data. Let us do our work, and we'll come out with good recommendations, and let's not waste our time with communities. I have to say I couldn't disagree more with that. I understand it. I have a certain sympathy to where it's coming from, and I understand the trade-offs. I will tell you that when we have engaged with stakeholders, we found it extraordinarily helpful. I can't say, honestly, standing before you, that in all modeling projects I have done that. And some I don't have the luxury of having direct access to stakeholders. I'm working on a problem that involves data from 50 years ago, and I'm trying to reproduce patterns of childhood infectious disease dynamics from that time, and I don't have access to the stakeholders of that time. When we have worked in conjunction with stakeholders, though, both for the sense of buy-in and ownership, in the sense of that we've really had a model that's grounded, it's been amply rewarded. And often we find that there's a disjunction between what's formally documented or what's said pro forma and what's actually in place. That can be a pretty big and sobering difference. I will say that, people vote with their feet. And I spend a fair bit of time working with key stakeholders. I actually haven't done nearly as much as you might think from my comments working with communities. I have been involved in some modeling projects which have done that quite substantively, including some with our Aboriginal population. And I believe that the insights from there are extremely valuable. I have not chosen to invest a huge amount of my time in community-based work like Peter Hoffman has. And I learn from Peter, and I look at him, and I listen to what they found, and it is profound. And I believe it's part of the puzzle, but it also does, the time also has an opportunity cost. It takes you away from other things. And I happen to have invested a lot of my time into other aspects of elicitation of information that tap into observations from the trenches, but involve less huge time commitments in the human theater of things. And I include here our use of mobile phone technologies for crowdsourcing information and cross-linking to sensor data, etc. I've said yesterday, and I'll say again, I'm a big believer in the potential for new generations of health technologies to help fill in the gaps with modeling, and the need for them to fill in the gaps with modeling, the need for modeling to help with that process. But I actually haven't spent a huge amount in communities doing formal group model building and participatory modeling. And I think it's very worthy stuff, but I'm personally leaving most of it to other people. And you may say that's hypocritical, but I think there's a role for core competencies, and there's a role for sort of what are the unique values you bring to the table versus other people bring to the table. And I love the work that Peter's doing, and I'm so glad he's doing it. And I'm spending my investment of time elsewhere. But we do a lot with stakeholders institutionally. And when we've done that, it's been extraordinary in terms of what we've discovered, what we've been able to accomplish, what we've been able to correct in our models, because they have looked over the shoulders of our modelers. And I am a huge believer. I have absolute conviction in the needs to keep our models transparent so that we can show them to people who are interested, and they will basically get a lot of what we've got captured. Even if I'm not day to day spending my time, convening group modeling building sessions in our villages to sort of elicit understanding from people at that level, I'm still really trying to circulate our models broadly so that they can be looked at. And I guess that's kind of a mid-level thing, isn't it, Alan? There's kind of extremes. The first extreme which I talked about, the big science technocratic extreme, is look, we'll build it in the back office, we'll give you a real good model, okay? And we'll bring it to you and you should be happy. You've had a bunch of smart people working on it. My conviction is that that's not a helpful situation, and often it sets up the stage to have that model not used. I would note one of the big models like that in Canada was recently defunded. After huge amounts of investment, it was defunded. It was not seen as responsive to the needs. A great technical model, lots of good stuff in it, but it didn't have that breadth of support from stakeholders. And that's not an accident. It wasn't. They weren't going out and doing that. It had a very closed office feel. You tell us what we want, we'll develop it in our offices, and we'll give you the results. So that's not an accident. It's not it's a reflection of the causes and conditions they created. Now, and the other extreme is, you spend your time in communities building up causal loop diagrams and diagrams of the Atkinson-McDonald variety, which elicit participant, population members' sort of perceptions, and you use them to build up the models. And I think that's great when it's done, but there's a lot of problems I work on where I'll turn to social scientists to do that sort of work to get the ethnographic understanding. And I'm a huge believer in mixed methods, which bring together rigorous modeling, sensor-based data collection, crowdsourcing, mobile phone-based techniques with this sort of ethnographic study. I think that's dynamite, and I think the ethnographic studies are extremely important. and they've given me a lot of insight in things where I've used modeling to complement my lens. But there's that mid-level where I'm really comfortable, which I'm absolutely convinced is needed, which is working alongside other stakeholders and showing them the model on an ongoing basis, getting them to run it, getting them to interact with it, getting their critiques on it, showing it while it's running so they can comment on it. I believe that that's really essential. Jeff, do you want to comment on this?
I'll try and keep it short. I guess we can talk about it when you're not here. Well, probably more often for a diminishing amount of time these days. And we're all fortunate for that. Again, I just really think of the fitness for purpose. That really drives everything I do about modelling. Yeah, what are you going to use it for? Short versus long-term trade-offs. A lot of it is really about change. I mean, I say, how do we have change, really? We want to intervene in a system. So as an engineer, my job is to change the system or build a new system better, rather than predict what's going to happen in the base case. And therefore the counterfactual body becomes important. In terms of, so again, one of the decisions you want to influence or change or improve. And often, sometimes there's one big decision. Will we invest, for instance, in what programs and what order do we invest in the national e-health program, which we've modelled twice in 5 years. Doesn't make much difference, but we could tell them why they were wrong. We told them before. So again, that's an abject failure, I guess. But we learned a lot. So one of my favourite sayings is that models are like children, they're not very attractive unless they're your own. So this idea of buying and going, you have to do what it takes to get the ownership. Who really needs to own this model? And my idea of a successful project is when the sponsor, maybe it's a clinician or a manager or a policy maker, basically about right near the end of the project usually, they elbow you out of the way and they start presenting the model. So that's perfect, that's perfection. Yeah. And so that's my criteria for success. I guess we're in kind of riding three horses at once, being in the circus. You've really got the research modelling, and that's really about acceptance by your peers, i.e. you're going to get funding, you're going to get published, and that's pretty much a ritual based on the norms and what have you. Consulting is pretty straightforward. You either get the bill paid or you don't, and you basically get more work or you don't. So that's pretty straightforward. But I guess I basically, I really see models are about learning. I think I've said a lot. How can we learn faster? So this idea of education, we model to actually learn faster, to help ourselves think more clearly. And the big problem is ourselves as modelers thinking clearly, because certainly in the projects, the modeler probably learns more than anybody else, really. That rigour of having to actually make it computable is really quite good. And the biggest mistake we've always made in a modelling project is we haven't run enough people along with the learning process. And you get too far in front of people and you lose, you actually can't talk to them anymore. It's actually people who are about the same level of expertise learn together much more effectively than experts and novices. And Barley's done a lot. So I basically say, again, this idea is that the purpose, the fitness for purpose and the purpose of a model changes during a project. And who do you have to bring along and what part of the project? And therefore you use totally different methods. I guess my great dream is that This isn't in research, consulting and education. This is in everyday decisions that have been made in health and healthcare. How do we actually add a modelling and simulation dimension to pretty much everything we do? Now, I don't know how to do that, but we certainly have to build good models, and we have to make sure they're relevant. So this is this idea. So how do you make it operational? How do you do that? I look at engineering-based industries because modelling and simulation pretty much is the norm. BHP Billiton probably modelled over 30 years almost every decision they've made. And again, where you've got senior executives from engineering backgrounds, that's the norm. It's certainly not the case in health and health. That's probably about all I want to say about it.
Good. Okay. So we're about to switch gears to some modeling. How many people in here would like a health break before we do that? Okay. Okay. We'll break. Maybe we'll be back within 5 minutes. Can we do it? Or do you need 10? 5? 5. Okay. Make it 5.